let's look at another example that is a little simpler, as a matter of fact, but it might be easier to recognize it as a perfect square. So let's say we have a problem where you're told to factor x squared plus 6x plus 9. Okay, so in this situation, it's easier to recognize because it's easier to recognize that this middle term is going to be 2ab. So let me show you what I'm talking about. So if we look at this first term, the square root of that is x. We look at this last term, the square root of that is 3. And so if we multiply the two of these together, we get 2 times x times 3, which is in fact 6x. So another way to look at it is if I take the square root of the last term, if x squared ever has a coefficient of 1 here, a leading coefficient of 1, then we really just have to look at the numbers. And if the square root of that last term, 3, is doubled and gives us 6, then we're going to have a perfect square. So 2 times 3 times x is 6x, so we do have a perfect square. So the way our rule works is, I'll go ahead and write the rule, and then we'll see if we can identify it. A squared plus 2ab plus b squared. The way the rule works is it becomes a plus b squared. So all a is the square root of the first term, b is the square root of the last term. And so therefore this should become x plus 3 squared. Okay, and we know it works because that middle term is going to be 2 times a times b. All right, very good. So that is the first of our special cases. The second of our special cases is called difference of squares. All right, so when we're looking at difference of squares, let's go ahead and write that down since this is our second special case. Difference of squares. Oopsies. Difference of squares. All right, so maybe it would be helpful if I go up here and I say, okay, this is going to be special case number 1, and this is going to be special case number 2. All right, and as we did before, let's start off by looking at the binomial situation and multiply it out, and let's see what it turns into. So maybe then later on when we're asked a factor and we see that the end result, the multiplied result, we can recognize what it is and be able to go backwards and take a shortcut. All right, so let's look at, okay, first of all, what a difference of square is it means that you have, let's maybe just define it real quick. So difference of squares means that you're going to get a squared minus b squared. That's a difference of squares. So it's that is a term squared minus another term squared. That's what it means by difference of squares. All right, so let's take a look at a specific example. So let's say we have x minus 3 times x plus 3. Okay, this is an example of two binomials being multiplied together. All right. Now, as we multiply these two binomials together, you're going to get the first terms, which is x times x. You're going to get the outer terms, which is 3 times x. You're going to get the inner terms, which is minus 3 times x. And you're going to get the last terms, which is negative 3 times positive 3. So plus negative 3 times positive 3. And then we're going to multiply it out. We get x squared. Now we get 3x minus 3x. And notice what happens is that you actually have these two cancel each other out. And then over here we get negative 3 times positive 3, which is positive 9. So this situation is kind of similar to the last situation where you had a squared plus 2ab plus b squared. So the similarity is this, in that you had the two terms. Let's scroll way back up. You had two terms that were identical in the middle. So you had the a squared and you had the b squared, but you had two terms identical in the middle, and that's why you get 2ab. This is kind of similar, except the difference is they are the same terms, except one is positive and one is negative. So instead of getting 2ab, we get 0ab. We get 0ab because they cancel out. Okay, they are identical, but they're opposite in signs. And then the other difference is that your final term here is going to be, oops, I said plus 9. Let's change that to minus 9. The final term there is going to be negative 3 times positive 3. So you're going to have a negative b at the end. So you can see that the difference of squares We have it here because this is a square, and this is a square, and because there's a minus in between, we call it a difference of squares. So let's take a look here. So this would be square root of x squared gives us x. Square root of 9 gives us 3. So we have something that is a perfect square in of itself, and another thing is perfect square of itself, and then a minus in between, so it's a difference of squares. So the general rule is going to be this. So here's our general rule. Let's see, what color did we do that in the last time? Green. Let's stick with green now. The general rule is this, that if you have a squared minus b squared, what's going to happen is you're going to end up with a minus b times a plus b. And that's how you factor it. And this is much, much, much easier to recognize. So the first special case that we looked at is kind of hard to recognize. It's kind of hard to recognize that you have a perfect square trinomial. You have to recognize that you have a 2ab in the middle. You have an a squared, a b squared, and 2ab in the middle. That's what you have to recognize it's a perfect square trinomial. But this was much, much easier to recognize because it's very easy to recognize that you have a difference of squares. So as you'll see, we end up with x squared minus 9. And so what is this first term here? This is the square root of that. And what is the second term? 3, it's the square root of that. So, and you just end up with, so basically it's like the same binomial multiplied by itself, kind of similar to what we'd learned in the previous special case, but the difference is our signs are different. We have 1 minus 1 plus, and that's what causes the middle terms to cancel out. And that's also what caused the last term to be negative. Okay, so again, this is much easier to recognize. The reason why it works is because of those middle terms canceling out. But again, it's much easier to recognize. So let's look at one more example. Let's say we have, you're asked to factor 4x squared minus 36. Okay, so you're asked to factor that. First of all, it's not even a trinomial. So that's helpful to recognize something different's going on here because it's not even a trinomial. By the way, you can factor this using our typical trinomial techniques. You just have to rewrite it as 0x in the middle. So say 4x squared plus 0x minus 36. And then you can actually follow the same techniques we did before. But we don't need to. We have a shortcut here. And the shortcut is to recognize that this is a difference of squares and ask ourselves, what is the square root of that? Okay, and that's going to be 2x. What's the square root of this? And that's going to be 6. So once you know your square root of that one and the square root of this one, it's just going to become, and here, let me write the rule down here first. A squared minus b squared is going to become a minus b times a plus b. Okay, so if this first term is a squared and the second term is b squared and there's a minus in between, then this is what it becomes. It becomes basically the same binomial multiplied by itself. It's just that the signs are different. Okay, so that means this is going to become whatever the square root of the first term is. If this is a squared, a is 2x. And if this is b squared, then b is 6. And then there's a minus, and then there's a plus. Okay, and that's how you do it. That's how you factor a difference of squares. Again, it works with our traditional technique. The reason why we touch those other techniques is because they work every single time. And if you come up with a middle term of 0, it would still work. But this is a shortcut. It helps you to solve the problem quicker and easier. All right, so go ahead and write a 2 to 3 sentence summary over what you learned today. Thanks for listening. Thanks for learning.